I'm going to talk about JA3. The code for it's there on that GitHub, so if you want to just like skip to the end, you can look at it. So last year at ACOD, I was talking to Jason Craig, and I was like, hey Jason, wouldn't it be awesome if we could fingerprint SSL clients, like how we fingerprint HTTP clients, and then we could see malware when it communicates out to even legit domains based on how it communicates and not what it's communicating to? Wouldn't that be like super freaking awesome? And Jason was like, yeah. So then we did it. And so here's the problem statement. I got a diagram here. You got a client on the left-hand side, server on the right-hand side, and in the middle you have your NIDs, your network monitoring or whatever. And then traditionally, we just see an SSL connection with the source IP, destination IP, and then maybe you'll get some like certificate information if you're lucky. But that's it. But there's actually a lot more that you can get out of the SSL handshake. So this is how it works. Client sends a send to the server responds SYNAC, client responds ACK, TCP three-way handshake. Immediately following that, the client sends an SSL hello packet saying, hi, I would like to talk in SSL, and this is what I can talk in. And then if the server's listening on SSL, it'll respond back with its SSL hello packet saying, okay, let's talk this way. And then they start communicating over SSL. So we're going to look at that client hello packet. This is what it looks like. I got two different clients here, and they look similar on the surface. However, the client on the left supports 13 cipher suites, and the client on the right has 19 cipher suites, and they have different extensions. So while it looks similar, it's actually different. So let's dive into some examples. Here's the Microsoft Edge browser, 19 cipher suites, extension length of 107, Dridex malware, 21 cipher suites, TrickBot malware, 12 cipher suites, and even fewer extensions. So you can see they're all different. And if you dive into the cipher suites in the order in which they appear, the Microsoft Edge browser goes from most secure to least secure, which makes sense, right? However, the TrickBot malware goes from more secure to less secure than most secure to less secure, and it's all over the place, which is interesting. So we realized that we could fingerprint SSL clients based on this data, which is the TLS version, the cipher suites, the order that they appear, the extensions, and the order that they appear, elliptic curves, and so on. We had an elliptic curve and elliptic curve point formats just to add like extra complexity to the fingerprinting process. So this is not a new idea, right? Fingerprinting based on the client hello packet goes back to like, I found this blog post from 2009. This guy, Ivan, was fingerprinting Googlebot just by looking at the accepted cipher suites that Googlebot was using to scan the internet. And then in 2015, Lee Brotherston released a tool called TLS Fingerprint, or Fingerprint TLS. And it was awesome. It basically did exactly what we wanted. It was fingerprinting SSL clients. However, it was a standalone tool that you had to deploy standalone, and the fingerprints that it outputted was just basically the entire SSL hello packet. It was huge, and so it didn't work in our environment, so we just couldn't use it. So we went out to basically create something that would. So here were our requirements. It needed to work on our existing tools, things that are already deployed in the network. It needed to be destination agnostic, so completely focused on the client, unique to the client application, easy to create, easy to share, and easy to consume by any tool. Basically, we wanted it to be simple. So this is what we did. We took the SSL version and the hello packet, the accepted cipher suites in the order that they appear, the extensions in the order that they appear, the elliptic curves in the order that they appear, and elliptic curve point formats in the order that they appear. And if there's one, there's just no delimiter. We take that long string. Basically we're just concatenating this together and delimiting each field, and then we MD5 hash it, and now we have what we call JA3, which is just a 32-character fingerprint of that. And then if there's no like extensions or anything, the common delimiter persists. So that's what it looks like. And the reason why we MD5 hash this instead of just logging the entire string is there's no limit to how many cipher suites that you can put into a hello packet. So you can put like 305, I think is the current like legit supported cipher suites in there. And so you could have this gigantic, really long string. And so that's why we MD5 hash it. So we just have a constant 32-character fingerprint, easy to share and easy to consume by all of our tools. So some examples, here's Google Chrome, here's Microsoft Edge, here's the Tor client, here's Dridex malware, here's TrickBot malware, all unique. So this is awesome because on the pyramid of pain, JA3 lives at the tools area, which is just kind of cool. So we're happy with that. So now that you know what JA3 is, welcome to Profiling and Detecting All Things SSL with JA3. It was written by John Althouse, Jeff Atkinson, and Josh Atkins. Hi, I'm John Althouse. I do detection in the cloud, and I like experimenting with things. Right now I'm experimenting with a late title card during a conference presentation. Let me know what you think about that. So here's what I'm going to talk about for the rest of the talk. Mapping JA3 fingerprints to client applications running JA3 on a large network. Detecting malware with it, pen testers, because that's fun. Targeted threat actor. Utilizing JA3 for hunting and analysis. And then JA3S, which is JA3 for the server hello package. Super cool. And then what you can get it with today. So mapping to client application. Trissel took Lee Brotherston's database of fingerprints and he converted them to JA3, and you can get that. It's a hit or miss. Some of those fingerprints are like from 2015. Some of them are recent, so it's and so we did some magic with our host-based logging and our network-based logging, and combined a best guess together, and we threw that up. It's on the GitHub, so you can download that. Using that, this is super cool. So using that, we can get an idea of what's running on a system just based on the network data. So we don't have to have a client, endpoint telling us what's running. I mean, it's still, you need that, but the idea is that you don't that you can get a lot of data basically just from listening to the network traffic. So this right here, this is this laptop, and this is accurate because most of what I do is just in Google Chrome, and then I got some random things happening there, and then there's one that's not filled out, but it's an internal tool. That's why. In a large corporate network, or example network, I guess, you can see a lot of Google Chrome, and then Firefox is way down there. It's interesting. So what if we start looking at the domains that these things are communicating to? If we pick like m.google.com, so we're picking basically, or we're looking at mobile devices. With this, we can see that 96% of the devices in this network are probably iPhones. What about my PC master race brethren? So you can see here, got most of them using actual Steam, connecting to it, and then some people are just like browsing the forums or seeing what's on Steam sale today. Just kind of cool. So sandboxing. What a lot of people want to do is they want to put JA3 into a sandbox, and then see what when they throw malware into it, like what fingerprints does it generate. But it's important to baseline your sandbox. Because some malware, some programs could use the operating system APIs that are in that sandbox. So this guy wrote this tool. It's on GitHub there. And it basically what it does is you just drop that into your sandbox. It communicates out over all the existing OS APIs, and then that's your baseline. And so if you see anything that communicates over that, that's good. That's still good to know. But if you see anything that's not using any of these JA3s, then you know that it is communicating with its own method, and that JA3 is probably unique to the malware. All right, so I like detecting Metasploit. It's fun. Last year I talked about this, basically detecting Metasploit with the cert, and it was easy, and this was that. And then immediately after I talked about this at Nova Hackers, this guy, HDM, updated the way that it was generating its cert. So I was like, all right, HD so-called M, let's do this. And I built detection for that, and it was also easy. But now this year, it gets updated again by R. Whitcroft on October 5th. And he's basically taking the best of those previous two methods of building a randomly generated SSL cert. So you could detect it this way. However, 20 days ago, it got updated again, and this time there's actually a bug in the code. So with their subject and issuer, they're doing C equals, then new line, then C equals US. And this is completely anomalous, easy to detect. But the problem is that this is just happening too often. It's changing too often. And so now that we have JA3, can we detect Metasploit based on how it communicates rather than what it communicates to? So here's what it looks like in Moloch. And by the way, if you don't know what Moloch is, we actually talked about it yesterday. Moloch's awesome. But get Moloch version 20 or later because it actually has JA3 built into it.
Oh, you're the man. You're the man.
It's in there now. So if you get the latest version of Moloch, you have JA3 and you can just start playing with it. Anyways, this is what it looks like. I ran 3 different iterations of Metasploit against Windows 10. And I'm going to zoom in here. You can see all the black lines. It's super cool. All the black lines are the stager, and all of the gray lines are the payload. So the stager is always the same, and the payload's always the same. And if I zoom in here, you can see that the stager is always between 160 and 170 bytes, or packets. And then the payload is, however long your Metasploit session is going for. And this is actually pretty awesome. So Metasploit does communicate using an OS API. I think it's the DLL API for the payload, but I don't think it does it for the stager. So that's interesting. However, Metasploit does have this module from interpreter WinHTTPS, which is supposed to use that OS API, that same OS API for the stager as well. And you can see it just has the same JA3. However, still those interesting packets for the stager. So you could detect Metasploit or interpreter by looking at the stager and the amount of packets, and then the payload. And if you see those together, then you can detect it. And I'll probably build like a Suricata signature, and I'll throw it out there. All right, let's move on to PowerShell exploit kits like Empire. And I was like, how am I going to detect this? This is weird. However, it turns out that Windows does not communicate over PowerShell natively. It doesn't. And I was actually surprised. I was like, sure, like they would do Windows updates over Power. Nope. So Windows only communicates over PowerShell when you tell it to. And so an easy way to detect something like Empire or any of those PowerShell malwares is if you have a lockdown environment, just look for PowerShell going out of the network, the PowerShell JA3. If you have something configured so PowerShell is communicating out to somewhere, then you probably know what it is and it's probably predictable, so you just whitelist that domain and then look for anything else. And that's how you detect, PowerShell exploit tools. It's actually pretty simple and amazing. Yeah, that's definitely a malicious domain. So what about custom targeted malware? So this is malware that was targeted specifically at our network to bypass our detection mechanisms. And it turns out that it's actually really easy to detect. You can see there's only a single cipher suite here. Nothing uses a single cipher suite. Not even TrickBot used a single cipher suite. It had 12. So it was very anomalous, very easy to detect. This is the JA3 string for it. And if you're wondering how to like, it's easy to detect that when you know what you're looking for, but how do you find that? Well, look at that fingerprint string. And our bro script that we open sourced, we made it so that if you just uncomment some lines, it will also log the entire fingerprint string. And if you search based on that for like, single ciphers or any anomalies like that, turns out this is really easy to detect, even if you don't know what you're looking for. All right, moving on to like hunting for like weird search subjects. You can just hunting through the logs. These look super weird. So I click on them, and I find the JA3 associated that's communicating to that weird domain with the weird search subject. Then I can pivot on this because this is the client fingerprint, and we can see all of the domains that it's communicating to. So this means that I don't need to build some crazy like DGA algorithm thing to see all the different domains that this DGA thing is communicating to. I can just look at the client and see where it communicates to, and basically the client can fill out all the detection for us. So easy. It's awesome. I love it. Another great thing about this is it doesn't matter if the server is going to respond on SSL. Because immediately following the TCP three-way handshake, the client sends the hello packet. If the server's not listening on SSL and just ignores it, it doesn't matter. We've already fingerprinted the client. So even if their command and control servers are not configured or not set up or whatever, we're still detecting it communicating out. So it is important to remember that collisions can happen with this. That is like two different applications having the same fingerprint as possible, and there are OS APIs that malware can use or any programs can use, but it's still valuable information to have. All right, so now JA3, yes?
You're getting, so you say collisions can't happen, but you're generally seeing someone's using a Windows API, you've just got tons of fingerprints.
Yeah, so yes. I'll get there. All right, but I want to talk about JA3S. This is fingerprinting for the server hellos. Doing pretty good on time, sweet. So here's my hypothesis. For a client, all right, hold on, let me go back. A server will respond, or a server can respond to different clients differently, but it will always respond to the same client the same. And let me show you that. So in this example, this client communicates to the server, and its hello packet is just all A's, for example. And the server's like, okay, hi A, let's talk A, right? Different client sends all B's, and then the server responds, oh, hello B, let's talk B. It's the same server, just different clients, and so the way that it's communicating back is different. However, for each client, it's always the same. And so what can we do with that for detection? Well, so I got an example here. These are two clients, JA3 on the left, JA3S on the right, so that's the server fingerprint on the right. So I did a bunch of tests just to verify that this would keep working, and it does. So for the client on the top, the same server is always responding with the same server hello packet, always the same. And then I used a different client, same server, and that's always responding with it's a different JA3S, different fingerprint. However, it's always the same for that client as well. So let's go back to Metasploit. This is the JA3S, the server fingerprint for Kali. It's pretty interesting. Kali actually, and this is the latest version of Kali, it uses the least secure of all the cipher suites that Metasploit supports, which is odd. So built-in detection just based on the JA3, like for Windows 10 interpreter. In our example network, we got a bunch of events. It's rare that an application will use this OS API. However, in an environment with like 100,000 end nodes, rare is relative. So can't really build detection just based on that alone. What about for that server fingerprint? Well, it turns out that that happens sometimes as well. So detection just based on that is just maybe not the best idea. However, combine them together, because remember, the server will always respond to the same client the same. So you take that, combine it together, the JA3 and the JA3S, and that's it. That's your detection mechanism for Metasploit. It's that simple. No. Yeah, it's awesome. So yeah, so that's it. So I know what you guys are probably thinking, especially if you're running JA3 in your network, you want this JA3S. And I don't think it's good enough yet. Right now, all I'm doing is I'm just looking at the version of the server hello packet, the cipher that it chooses, and the list of extensions that it has. And I think there's a lot more that can be had there. And I know some other people have already figured this out, but they work for government organizations and can't tell me how they did it. But I know that it's possible, and so I'm looking for input from the community, from you guys. Let me know what you think I could add to this to make the server-side fingerprint, I guess, more unique and I don't know, valuable. So.
Is there any reason why you're not indexing the pre-hashed value? Like you concatenate a bunch of strings or a bunch of numbers with commas. Wouldn't you want to be able to mine that with, okay, show me everything that has less than 4 cipher suites offered?
Right. Oh, yes. So the question is there value in indexing and I guess logging just the accepted ciphers as well as like the JA3 fingerprint? And the answer is yes. However, there could be like 300 ciphers, so it's basically up to you and your logging platform and how much data you're willing to ingest, and if you're concerned about your logging or alerting platform having like a string that just continues to run on forever.
Let's talk about malware, for example.
Oh, yeah.
Is there any reason why you couldn't just uncomment right before you hash your JA3 and then send that to ES as well?
Yeah, you can. Yeah, you should be able to do that. However, Andy had to write a custom module for JA3 on Moloch, so to ask Andy, I guess. All right. So in conclusion, JA3 is not a silver bullet. Collisions can happen. Malware can use a OS API. So it's not always going to be like just a silver bullet for detection. Like I said. And they're also good to note, as you may have seen with Google Chrome, there was a whole bunch of fingerprints for Google Chrome. There can be up to 5 JA3s for any application, especially like legit applications and web browsers and whatnot. And that's because there's different extensions in the hello packet for if it's like renegotiating an existing session or if it's communicating direct to an IP, it will not have the SNI field. But if it's communicating to a domain, it will have the SNI field in the list of extensions, so that you can have a bunch of different JA3s for the same application. However, malware usually just has one, which is cool. This is always valuable as a pivot point for analysis, no matter what, even if it's using an OS API, even if it's like a shared with some other legit program or something like that, it's still valuable. This is basically like, think of it kind of like the user agent string and an HTTP request. Like, it's never invaluable. Sometimes it might not be your sole means of detection, but it's still always something good to have to look at. Also, JA3 is a silver bullet, sometimes. So like in that instance where there was that custom malware specifically designed for our environment and specifically designed to bypass our detection mechanism, it was actually like shooting fish in a barrel. It was so easy to detect. It was crazy. So. But each environment is different, so I know a lot of people ask me, like, when are you guys going to release, like, a blacklist? And the problem is that while one blacklist may work great in our environment, it might not work great in your environment based on the devs and programs that you're using versus the programs that we're using. So it depends on each environment. Still always good to share, though.
Is adding new, like, they have newly observed domains, newly observed JA3s, is that something that you look at? Like,
Yes.
pass it on that, and as soon as something new comes up, go, oh, what's this?
Yeah, so the question is, or comment, I guess, is can you use newly observed JA3s just like you use newly observed domains as a means of detection? And the answer is absolutely, and we're doing that, and it's awesome. JA3S adds even more context. Sorry, I just want to finish up here. JA3S adds even more context, and I'm so excited for getting that out there and completely deployed. But like I said, right now, I just think that there could be more to it. Or if you guys think it's good as is, let me know, and I'll throw it up on the GitHub and open source it. Yeah.
Beta.
So yeah, please help contribute and iterate. The reason why I'm doing this is I just wanted to push the industry forward. So many people ask me, like, hey, now that you've released this, aren't threat actors just going to get around it, and then it'll be like built into Metasploit, and then it won't be valuable anymore? And my answer to that is, if we just held this and kept it close to the chest and didn't release it out to the community, someone else who could really use this will probably think about it and then start developing it on their own, and then they have to go through the months that it took us to figure out how to do this right. The thing is if everyone is inventing the wheel in silos, how long is it going to take for the industry to invent the cart, right? So if I release this out, my hope is that you guys will all be like, oh, I know how to do that better, and then make it better, and then release that, and then we can all just grow our detection capabilities as quickly as the attackers' capabilities grow, because they all just release all their stuff at DEF CON. So where can you get JA3 now? We open sourced our Bro module and Python module for it. It's built into Moloch. There's an Nginx module. It's part of MISP. Corelight can use basically anything that runs off Bro. So I bet FireEye is probably using it, but they won't tell me. Darktrace is using it, and they're using it very successfully. It's on the abuse.ch backend. There's a push request for a Suricata module, and hopefully that'll get done soon. Reservoir Labs, yeah, so it's pretty awesome. And again, my name's John Althouse. You can contact me by this method. If you're running Bro in your network and you want JA3, just type bro package install JA3, and it's installed. It's pretty cool. That's it.
Do you have a
Yeah,
Do you have like a catalog? So you mentioned like you guys sort of hack something together where it shows the JA3s, comma, like what you think it is. Is there some sort of indexed? To your point, I'm all about like the data and being able to comb through it because you don't know what you don't know.
Right.
Is there some sort of catalog that we collectively could log into, punch into JA3 to search to get just an example of what the output would be? And if we knew what it was, like, could we then suggest a label, aka tag it?
That sounds awesome. So the best way I think of potentially doing that is, and I've talked to VirusTotal about this. I think it would be best for VirusTotal to be using JA3 and have it on their paid service where we can all go in and find out like what applications use this, based on what everyone uploads. They're open to it. However, they just haven't done it. And so if you're a VirusTotal customer, contact your account manager and ask that they do it.
Would you be open if someone put together the application that did the cataloging and
Absolutely.
allow the facilitator? Okay.
Yeah, if you want to do it, yeah, awesome. That would be amazing.
I got a question about JA3S. Is the uniqueness of the server reply to each client, is it purely a function of it being a subset of the cipher suite offered by the client? Is it just the ciphers that's unique because of that?
So it's basically what's unique about it is the version, the cipher that it chooses, and the extensions that it uses. So.
I mean, it has to be out of, if I remember correctly, it has to be out of the range of the ones that were offered by the client, correct?
Right, yeah. It has to pick what's being offered by the client. So there's potential for basically fingerprinting all the servers on the internet by custom building a certain client hello packet, maybe with like all 305 ciphers, and then just spamming the internet just to see what the servers respond with. So that's, an idea.
So we're running this in an enterprise environment.
Go do that.
So we're running JA3 in an enterprise environment. And,
Yeah.
And when the guy who's doing that was talking to me about it, I was thinking, oh, come on, man, that's not really going to work. Nobody's going to write their own handshake. Everybody's going to just use a library and not even know what handshaking is or whatever. And I was shocked at the diversity.
Yeah.
Why is that? Because isn't that really weird that malware authors are negotiating ciphers and picking them on their own and not just jacking something?
So yeah, some people, I guess, like in that particular example where it was custom built, maybe they were choosing it on their own. I don't know how they came to that. But normally how a client creates its hello packet is all based on the libraries used, the version of those libraries, and maybe even the version of the operating system and the different operating systems. So there's actually a lot of variables there. And so not everyone's going to build their client the exact same way with the same libraries that like Google uses to build its master Chrome client, which is, it's awesome. It works out for us, I guess.
Anybody else?
So I'll caveat this saying that it's a naive question. Is there a capability of you putting this on a host so I can actually bind it or I can determine what process it is that's generating that fingerprint and then put that in things like Cuckoo?
Yeah, so it's totally possible. What's his name? Was it Andrew Morris? He made a Twitter post where he basically had a one-liner, with TCP dump and like the JA3 Python code, and was basically able to use that to just dump out JA3s on the host. Now, if you could combine that with something that's looking at the client details, like the netstat output or something like that, then you could do that. It hasn't been written yet, but it's totally doable. I would think that there's potential for maybe like an OS query module to make this happen, but it doesn't exist yet.
So for sandboxing, TLDR already couples the host-based data, this binary called out to this network. There's no reason why I can't just add the JA3 field to the TLDR output so that you'd get that within Phoenix. I'll do that tonight.
And this is why this conference is awesome. All right.
Everyone's salivating for this, man.
Well, I noticed something here. There's a Salesforce in the middle of that GitHub. Is there any opportunity that Salesforce will let you release this properly open source where it's not tied to the company, or is it already like that?
It's already like that. It's BSD 3 clause. It's open source, and you can contribute to it. So you can do pull requests, and Salesforce allows that. So
okay,
yeah,
just making sure.
Thanks a lot, John. That
All
was
right.
freaking awesome.